Welcome to Business Statistics. Today we're covering Chapter 1, all about data. In this chapter we're going to talk about what is statistics, how is statistics used in business and economics, what are different definitions of data, what are potential data sources, some descriptive statistics you can use, and some examples of bad statistics. So what is statistics? Well, it's a branch of mathematics taking and transforming numbers into useful information for decision makers. I'm sure you've seen during election times people put up polls about which candidate is better than the other. These are a form of statistics. They're letting us know something about what the population thinks by just sampling a small group of people. We're going to understand methods for processing and analyzing these values, these numbers, and we're going to have these methods help us reduce the uncertainty inherent in making business decisions. So why study statistics? Decision makers use statistics to present and describe business data and information properly, to draw conclusions about large groups of individuals or items, using information collected from subsets of individuals or items, make reliable forecasts about a business activity. So how much inventory should you hold on during the Christmas season? When should you start letting go or hiring new labor? You want to improve your business process. Are you actually serving enough customers in a limited amount of time? Exactly how many calls does your call center answer and respond to in a given hour? How could you determine if advertising is working, if your price is too high, if employees are working efficiently without statistics? Here's an article from the Wall Street Journal, and it's looking at data crunchers, now the cool kids on campus. More and more, we see disciplines going deeper and deeper into using statistics within their discipline. It's estimated that just knowing or having a very good foundation in statistics can increase your potential wages by as much as $10,000 per year. Before we can start learning from data, we need to define data, ask where does it come from, and how do people use data. In this chapter, you'll understand the types of variables used in statistics, know the different measures, scales, know how to collect data, know the different ways to collect a sample, and understand the types of survey errors. A variable is a characteristic of an item or an individual. For example, if you need to describe your physical appearance to someone who can't see you, what would you say? You might describe your hair color, your eye color, or your height. Each of these is a variable. Data, the set of individual values associated with a variable. Going back to your physical description, the variable eye color can carry many different values. Green, blue, or brown. Let's suppose your eyes are green. Your hair color may be black, and your height is 5'6". For any one person, these variables will hold only one value for each variable, and that set of values would be data about the person. Statistics, the method that help transform data into useful information for decision makers. Let's suppose the person you're talking to uses the metric system of measuring. You are quick on your feet, and you describe yourself as average height. In this case, the average height in a population is a statistic. The person understands average height even if he doesn't use the English system of measurement. Variables are divided into two major groups. Categorical, which are qualitative variables, have values that can only be placed into categories, such as yes and no. Numerical or quantitative variables have values that represent a counted or measured quantity. Discrete variables arise from a counting process. Continuous variables arise from a measuring process. Categorical variables, example, marital status, political party, eye color, and discrete variables, for example, the number of children you have, the defects per hour. These are items that are counted in whole values, not halves or quarters. You don't have a quarter of a kid or half of a kid. Continuous variables are things like weight, speed, and income. These are measurements. Within data, there are different levels of measurements. First one we're going to talk about is called a nominal scale. Nominal scale classifies data into distinct categories in which no ranking is implied. Nominal variables are just categories with no specific order. Do you have a Facebook account? Yes or no? The type of investment. Do you want growth, value, or other? Depends on your preference. Cellular providers. Do you have AT&T, Sprint, Verizon, other, or none? Ordinal variables can be either numeric or categorical, but the key difference is that order matters now. Right? For example, student class designation. You can be a freshman, a sophomore, a junior, or a senior. Product satisfaction. You can be very unsatisfied, fairly unsatisfied, neutral, fairly satisfied, or very satisfied. Faculty rank. Your professor could be a full professor, an associate professor, an assistant professor, or an instructor. Standard & Poor's bond ratings. You can have the highest level of AAA, just below that AA, then single A, and we can keep on moving down as the bond gets worse and worse. Even your grades are an ordinal measure. We know that A is better than B, and B is better than C, and C is better than D. We can agree that very satisfied is better than fairly satisfied, but we cannot all agree on the boundary between fairly satisfied and very satisfied. That's one of the issues associated with ordinal scales. Ordinal numerical values, where the distance between values matters, are considered interval variables. Ordinal numerical variables, where the distance between values matters, are considered interval variables. An interval scale is an ordered scale in which the difference between measurements is a meaningful quantity, but the measurements do not have a true 0 point. Example of interval data are time of day, could be 12 hours or 24-hour systems. Temperature could be Fahrenheit or Celsius. A ratio scale is an ordered scale in which the difference between the measurements is a meaningful quantity and the measurements have a true 0 point. Unlike time or temperature, where the 0 point is dependent upon the scale, ratio variables have a true 0. Examples are income, number of children, distance measured in centimeters or miles. Other examples of interval and ratio variables can be found in the chart below. As we previously discussed, temperature is one of those interval variables. But your standardized exam scores are also an interval variable because it's measured differently on the ACT or the SAT. Your height is a ratio. It can be measured in inches or in centimeters, but it has a true 0. Same with weight, age, and salary. So why do we use data in business? We want to answer a business question. For example, we may use data to find out how effective an advertisement is at attracting new customers. Pharmaceutical companies need to test the efficacy of a new drug before it can bring this drug to market. Quality control managers may collect the time it takes to complete an order at a Dunkin' Donuts drive-thru. Each of these are examples on how data can help us solve business problems. Before we can analyze the data to use it in business applications, we need to find an effective way to collect data. We need to avoid data flawed by biases, ambiguities, or other types of errors. It doesn't matter how sophisticated your statistical analysis is if your data are flawed. Then so too will be your results. We have a saying, garbage in, garbage out. For example, suppose you want to know if high school GPA is a good predictor of getting admission into college, and you only ask college students what their high school GPA is. you would be leaving out a very important group of people, individuals that went to high school but not college. Your results would be biased. When it comes to data, there are two main sources, primary sources and secondary sources. With respect to primary sources, you are the data collector. You write the surveys. You construct the variables. You collect the data. Secondary data are data you obtain from a third party. Lots of big data analysis is data collected from third-party groups. Please watch the video on big data to get a better appreciation as to how many things are collecting your information. Sources of data fall into 5 categories. Data distributed by an organization or an individual, the outcomes of a designated experiment or designed experiment, the responses from a survey, the results of conducting an observational study, and data collected by ongoing business activities. So think of that as scanner data. Every single time you go down the Kroger line, when they scan your item, that's going into their database. Examples of data distributed by organizations or individuals. We have financial data on a company provided by investment services. We have industry or market data from market research firms and trade associations. An example is scanner data, which is collected at the point of sale using the barcode on all the items you buy. Stock prices, weather conditions, and sports statistics in daily newspapers. Primary data is also collected in an experimental setting. For example, health data are collected in clinical trials. Consumer purchasing data are collected during consumer product testing experiments. Survey data relies on individual responses. These questions could be mundane, such as what laundry detergent do you use, or it could be more personal, like have you ever used illicit drugs? The main problem with these data are that people are free to lie. Therefore, survey data may have inherent measurement error. So political polls of registered voters during political campaigns are example of survey data. A survey asking people which laundry detergent has the best stain removing abilities. People being surveyed determine their satisfaction with a recent product or service experience. Examples of data collected from observational studies. Market researchers utilize focus groups to elicit unstructured responses to open-ended questions. Measuring the time it takes for a customer to be served in a fast food establishment, or measuring the volume of traffic through an intersection to determine if some form of advertising at the intersection is justified. Examples of data collected from ongoing business activities. A bank studies years of financial transactions to help them identify patterns of fraud. Economists utilize data on searches done via Google to help forecast future economic conditions. In fact, there's a study found that the Google Trends predictor can sometimes do a better job than the CDC to predict flu outbreaks. Marketing companies use tracking data to evaluate the effectiveness of a website. You may notice that whenever you search for particular products, they start to show up in your Facebook feed or in your other social media feeds. That's the end of this chapter. In the next section, we're going to talk about how we can actually sample data.